Okay, so to wrap up this idea of function algebra, I should have put that on that heading here. I was running out of room on that last sheet, so I thought I'd give myself a little bit more space. But to do some function algebra here, since we're building a new function by adding, subtracting, multiplying, and dividing the ones that we have, we should consider that the new function will probably have a different domain. And there's a lot of different ways to do this, but the one way that I'm going to concentrate on is, why don't we just simply build the function first, and then once we have the function, we'll see if there's any red flags that exist, right? And so that's probably the easiest approach based off of what we've seen so far in our little math careers and whatnot. There's actually other ways to do this that are maybe even faster, but I'm just going to go ahead and stick with what we know. So let's begin by, let's find the domain of f plus g of x. Right, so I'm going to basically take advantage of the fact that we've actually already found this. Right, in the previous handout, we actually found this to be x squared minus 6x for the functions that I had there. So what is the domain, right, for that function? And so basically what we're looking for is red flags. This is over 1, so there's no division by 0. I don't see a square root, so don't have to worry about anything positive. So there's no red flags. So I'm saying the domain is everybody. Everybody's going to work. We're going to be solid. It's a good function all the way around. Okay. What about something like earlier? Previously, we took a look at the function f times r of x. Right. What's the domain of this function? Well, again, looking at some previous work, right, what we basically did is we multiplied the two functions together, right, did some work here, and we found that function to be, let me write it over here, x cubed minus x squared minus 5x minus 3 all over x minus 2. So again, I'm taking advantage of some work we've previously done. So we already found the function f times r. So what's the new domain? Well, again, I'm looking for division by 0, and I have one. So we basically can't let x equal 2. As far as square roots are concerned, there are none. So my domain is basically everything to the left of 2 union everything to the right of 2. And again, if I drew a number line, we're throwing 2 out. We're everything to the right and everything to the left. So again, the best aspect is just find the function, and then once you found it, use our previous knowledge about domain and ranges to get us going. What about the function? What about the domain of, let's say, h plus g, or actually, excuse me, h minus g of x, right? What's the domain of that function? Well, again, we're combining a radical with this line. We've already done that. So looking over here at some previous work, right, we found that function right here, right? So this function is the square root of x plus 2 minus 3 plus 4x. So we've already done the groundwork. We've already found the function in a previous video. So how do I find the domain? Well, the first thing I consider is division by zeros. Well, this is all over 1, so there is no division by 0 in this problem, so that one we don't have to worry about. What about a radical? Well, right there, there's a radicand. So I have to make sure that the x plus 2 stays greater than or equal to 0. And then subtracting 2 from both sides, there's our domain, right? Basically, all x values that are greater than or equal to negative 2. Of course, on a number line, there's 0. Here's negative 2. We're including negative 2, and we're everything greater than it. So in an interval notation, right, that would be the interval notation for that. So again, find the function. I'm taking advantage of, we've already found these functions, and then basically doing our red flag argument, division by zeros or radicals. And then last but not least, here's another one. What about the domain of the function h over g of x? All right, and so again, we've already found that, right? That was here, right? So that function, when we put the function h over the function g, we end up with the function, the square root of x plus 2 all over 3 minus 4x. So how do I find its domain? Well, again, if we consider the division by 0, we do in fact have a situation, right? We have to worry about when that denominator is equal to 0. Doing some math, it looks like we're going to throw out 3/4. So as far as the division by 0 is concerned, we need to make sure that we're not equal to 3/4. What about the radical? Well, we've done that over here. Let me just do it again. For the radical, we need to make sure that x plus 2 is greater than 0, right? Whatever is underneath that radical, we have to make sure that it's positive. So subtracting 2, we get that. So if we put this all on a number line, right, here's 0, here's 1, here's 2, here's -1, here's, sorry about that, -2. So 3/4 is roughly about right there. So we're open at 3/4. We're not allowed to do that. But here, we're closed at -2, where everybody above it, we're going to have to skip over 3/4, and then where everybody keep on going. So this guy is good from -2 and beyond, but since we have to throw that guy out, there's going to be a little hole in our domain. So interval notation, it looks like we're talking -2 to 3/4 open, union 3/4 to infinity. And so there's how we find the domain for our new functions if we're doing some function algebra. Do the work, find the function itself, and then once you got it, it's a red flag argument, right? Do I have any division by zeros? You account for them. Do I have any radicals? We account for them. And then we basically piece our story together. So that is how we do it. So a nice review of what we did last week in part 1 when we were finding domains without a graph, right? Finding domains with red flags. So we can still do that with our function algebra. Okay, so that wraps up the function algebra. There's one more major idea in 3.1 that we do with functions, but obviously I'll do that in another part of our module in another video. If you've got questions, ask them on Canvas. Come see me during an office hour, whatever it takes to get this stuff down. Talk to you guys later.